Hello, everybody. Today we are going to talk about something that is called a three-way switch. Okay, so that's the topic of today's class. All right, now you have dealt with pretty much all of us are dealing with the three-way switches. We're using three-way switches almost every day. Imagine there is a light bulb, or there's a light or light bulb or lamp holder installed in the basement. Okay? So here's the basement. There's a light in the basement. And there's a light switch right at the bottom of the stairs. And there's another switch that is on top of the stairs. And you can control the light from either or of those switches. Okay? So you can turn on the light and you can turn off the light, and you can go upstairs and turn it on, and you can go downstairs and turn it off, and so on. So today I'm going to show you the logic that is the electric current logic that is behind all that. Okay? So now we have the we didn't print. Did you give us a quiz? No, I didn't. I'm still working on the question bank, so it's going to be released on Monday. Quiz, and then we're going to have a test. It's just like always going to have a week to do it, and it's going to be open book. And I'm adjusting the questions accordingly, so you have to look into our notes. Now, this lesson there will not be what do you call it? There will not be posted lecture notes. So all this here is going to be done on this video, and it's going to be posted on YouTube, so you can watch it as many times as you want and make notes. There's a reason why I'm doing this. I need you to have the whole concept of how to work the three-way switches all in your head, and then you can do the drawings or diagrams, but I want you to understand the concept of it. So it's important. Yeah. All right. Now, from previous lectures, we analyzed some switches and how do we count the ways of the switch. We dealt with the single pole switch. We dealt with the three-way switch, four-way switch, and so on. Single pole switch is like this. Yeah. There is one terminal here, there's another terminal here, and there is a pole. And you can either close that switch or you can open that switch in order to have continuity between these 2 points. Okay, some of them are momentary, some of them are latching. And pretty much the light switches that we use in our everyday use, they are latching switches. You can turn it on, turn it off. Okay. All right. Now, that will be single pole switch. Now, we're going to deal with the three-way switch. And three-way switch, how many terminals it will have, except for the ground, it's going to have 3. Okay. So, three-way switch looks like this. There is a common terminal here, and there are 2 other terminals, and there is a pole here that travels from either mixer connection with either of those 2 points. Now, this common point here is called common. That's the common terminal. And these 2 terminals here are called traveler. Okay. So, a three-way switch has 3 points of connection. Okay. This pole either makes a connection with this traveler, or it makes a connection with that traveler by the means of flipping the switch. Right. That's how we connect those. That's how the three-way switch works. Now, just hypothetically, if you have a switch with the terminals not labeled, obviously you're going to see which one is the ground or a bonding terminal, and quite often the three-way switches or single-port switches or four-way switches, they will not have a ground terminal because the ground or bonding is done through the way of this chassis here. That is connected right to the box. But some of them do have a separate terminal, grounding terminal, depending who makes it, who sells it, and so on. Now, if you employed a multimeter, and if those terminals are not labeled, how would you find out which one is the common and which are the travelers? Any ideas? I'll just give you a couple of seconds to think about that. All right, now, time is up. Common is black. Okay, that's good. In this case, we have the common that is black. Okay, and these would be the two travelers. Brass color. Okay. Well, let's say all of them are brass or the same color, and none of it is labeled. And you have a multimeter. How would you find out which one is the common? All right. Well, first thing I would do, now this thing has to be taken out of the circuit switch. It's a freestanding switch, all right? Not connected to anything. It's important because I don't want you to use a multimeter, and especially multimeter, switched on the continuity, in the continuity meter mode, and start poking around wires that could be connected to something else. All right. Okay, so first thing I would do is I will switch this multimeter into the continuity setting. When I have this meter set in continuity setting, if we touch these two leads, we should have indication that those two leads are touched and there's a full continuity between the common terminal and the working red terminal here. So let's see, we're going to touch that. Oh, look at that, nothing happens. Why doesn't it happen? Okay, let's say, okay, why isn't it's nothing happening? Because this thing is not turned on. So we're verifying it. Now we're going to touch that. Oh, yeah, we're touching it, still nothing happens. All right, because we're verifying it. We have to make sure that this meter works. Oh, look what happens. One of those leads are not pushed all the way. Right? Some of you have seen it, you know, that I actually unplugged it. So I would make a poor magician because you would see my tricks right through. All right, so now we have the meter set into continuity, and then we have the leads plugged in properly. Let's see if maybe there's a break in the lead somewhere, who knows, all right? Okay, we hear the beep. Okay, so now we have the continuity. All right, so using a continuity meter, how will we find out which one is common and which are the travelers? This is how we would do this. Well, if this is the way that this three-way switch works, then this common terminal is connected to either this one, this traveler, or that traveler, right? Either this or that, this or that. Any idea of which terminals will never, ever make a connection with each other, and it doesn't matter which way you flip the switch? Travelers. Yes, travelers will never contact each other. That's good. Well, here's a piece of information that we can use. We're going to verify that. Here's a switch that is flipped one way. And let's see here. I just connected that terminal, my lead, to one of the terminals. Nothing happens, okay? Now I'm going to flip the switch, and then I'm going to connect those again. Nothing happens again. All right, let's see if we have the common here. All right, this one doesn't work. But let's say if we keep one lead on the common, let's see if we can make a connection with either or of the travelers. Nothing here. All right, let's see if the other traveler works. Ah, look at that. It works. So now let's flip the switch. And if you flip the switch, you'll probably find out that this one is going to be disconnected and this traveler is going to be connected. Okay, here, flip the switch. Now this one is disconnected and this one is connected. So now we know that this is this terminal here is common. All right. So this is as far as the idea of how the guys, concentrate on what I'm doing here, because if you start chatting about video games on this thing, then either I'm doing something wrong, or maybe you need to get extra coffee because maybe it's boring. But whether it's boring or not, I don't think it's boring. I think it's pretty interesting. This is something. These are the basics that you absolutely have to know if you want to go into the electrical field. All right. It's not Friday yet. Tomorrow is Friday. All right. Okay. So now let's see how we can connect. How is it that this switch is made for our use, so we could connect? We can make a connection of simple 2 points and a light bulb, 2 light switches and a light bulb, without having to look at the diagram or without having to, excuse me. Okay. Now, let's see here. How is it that this thing is made so we can install this thing without looking at the diagram or having to draw it out? Okay, so this is how it works. Okay, I'm going to erase this. And we're going to draw through 2 switches and a light bulb. And the power is going to be supplied somewhere. Okay. First simple scenario here. We have one of the switches. I'll just make it smaller here. There's one switch. Okay. Here's another switch. Okay. So this is common. This is common. This is traveler. This is traveler. And over here somewhere, we're going to have a light bulb connected. Let's see here. The light bulb is going to be somewhere with its own terminals as well. And the power is going to be supplied to the first switch right here. All right, we're going to have a hot wire, and we're going to have neutral wire and ground or bond. All right, so first thing, here is a nice, nice kind of a structured way of connecting things. Well, let's start with the travelers. First thing we're going to do is connect travelers. So we're connecting the travelers just like that. Then we're going to connect one of the common, the closest to the light bulb, and we're going to connect that right into one of the terminals of the light bulb. The other terminal of the light bulb is going to go all the way down here, and it's going to connect right to the neutral. And then we're going to connect the hot to the other common. See what's going on here? So this is going to be one box. This is going to be the other box. And this is going to be a third box. Third electrical box or device box. So what did we do? We connected travelers together, grab the common, connect it to the light bulb, and grab another terminal of the light bulb, and we go all the way back to the neutral. Notice that the light bulb is not directly connected to a hot terminal from the power supply. These are the terminals of the power supply. Of course, the ground or bonding wire is going to have to make its way also to at least the first box, and if we're dealing with EMT, electrical metallic tubing or conduit, then the grounding or bonding is going to be carried through the metal part of the conduit. If we have PVC conduit, then we're going to have to install another wire that goes all the way to the last box, because the PVC doesn't conduct electricity, so we have to supply the other. But just for the sake of clarity, we're just going to leave that out for now. And we're going to concentrate on the electric current passages. Now let's say here's the pole, and it's connected to this terminal. We flip the switch. And let's say this one is connected to that traveler. Let's see if we have a current path when switches are flipped. There are two switches here, okay? There's one switch here, and the other switch right here. Now, let's see, because we have to have a closed pathway for the electric current to travel in order to make the light bulb come on. Okay? So the electric current travels from the hot through this common terminal, goes this way here. Oh, there's a connection, goes to the light, through the light bulb, and returns on the neutral. Wow, we have a connection here. Now, let's see. We're going to flip this switch. Flip this switch the other way. Okay? So that goes out, and now the common is connected to this. What do we have here? Do we have a closed pathway? It goes from the hot terminal, goes through the common, travels through the traveler. Whoops, there it goes. There's no connection. The light bulb is off. Now we can turn it back on here, or we can flip the other switch. And let's see if we have a connection now. Obviously we do. Electric current travels through here, through those travelers, goes that way, through the light bulb, and it returns on the neutral. Right? So just as a review of this particular scenario, what was the first thing that we did? First, do we have a light here? Oh, there we go. First, connect travelers. I'm just going to skip the word here, okay? We connected the travelers. Okay? And then connect one common to the light bulb or to the load. To load. That's our load, which is a light bulb. Okay? And then the other terminal load to neutral. Right? 3 steps. Connect travelers, common to load, and load to neutral in order to close the circuit. Right? So this is when the power is supplied to the first of one of the switches. Not always you're going to have that. You're going to have another different. You're going to have various situations where the power is applied somewhere else. Okay, so or the order of devices could be different. So let's just check it out. If we just switch these two, yeah? See what we can do is can we use this sort of structured way of doing things. I'm going to erase that. Okay. All right, we got the office environment going on here. People don't understand the recording. It's okay. All right. So now let's just have a different situation. Let's say we have a switch here. We have a light bulb here. I'll just put the light bulb somewhere. That way here with terminals. And we have another switch. Let's say here. Okay, so we have common, traveler. Let's just put the common on the other side here for more clarity. Common here, and then 2 travelers. Okay, all right, and we have 3 boxes. Here's one box. Here's another box with the light bulb. And here's another box with another switch. Okay. I'm just going to turn the light, dim the light a little bit so we can see the graphics a little bit better. Okay. Now, what do we have? We have to connect, and the power is supplied also to the first box. The situations could be different. Let's see if we can use the same kind of a scheme here. Here's a traveler, and here's a traveler. Okay, connect the travelers. Just going to go right through this box and connect the travelers together. Okay. Then we're going to grab the common from one of the switches and connect that into the load. So we're just going to go that way here and connect it to the load. So that's going to be the hot terminal of the load. And then the other load to neutral. Right? So it's going to leave this box, go through this box here and connect to neutral. And of course, the hat is going to be connected right here.
Do you find any of them around here that are doing that, or is this all control?
All right. And we have the poles here. Now let's see if we have a signal path, not signal path, current path that we can control. Let's say this thing is connected this way here. The switch are flipped that way. Of course, it's going to be ground. Now, the electricity travels from the hot, goes through this traveler, through the terminal here. Oops, there's a broken pathway. The light bulb is off. Let's see if we can connect the light bulb by any of those switches. Let's see if we flip this one here. Right here. Okay. Can we turn the light bulb on? All right. Hot travels here, goes through this one, travels through that, goes through the light bulb, and comes back on the neutral. Pretty simple. Connect travelers, common to load, load to neutral, and of course the power. Let's get the fourth point here. Power to hot. So not 3, 4 points we have to go through. All right. So that's the situation when the power is supplied to the first switch. But what if, and this is probably going to be the most common situation, is that the power is going to be supplied right to the lamp holder, right to the load. Also, what I want you to pay attention to is how many wires we have between boxes. There's 3 wires. If we don't have to connect the ground or bonding, 3 wires, 3 working wires. If we don't have to connect the ground, that's if the conduit it's a metal conduit. Okay. Also, but that you're going to cover that during the next term. But I'm just going to give you a heads up. We're also required that in every box there is a neutral wire pulled into the box. Even if it's not connected, it has to be there. But we're not going to include that. I'm just letting you know. I'm not going to include this thing right now because we're concentrating only on the current pathway. Yeah. Now let's see if we can supply the power right to this box right here, and can we use the same scheme? All right. There's a chat line going on. Is it about this? Anybody has questions so far? I don't see any. Okay. This is going to be our last lab. We're going to connect that after you bend the pipes or do the box offset and connect the conduits together. So we're going to supply the power now to the load. So what we have here, we have a 3-way switch here. We have a 3-way switch here. And we have our light bulb, which is here. Here's our load with terminals. And let's just label some of those here. Here's our common, traveler, traveler, common, traveler, traveler. Here's our box, device box. Here's our device box, which is most likely going to be a lamp holder with octagon box. and here's another box for the switch. And the power is going to be supplied right here. One is going to be hot, one is going to be neutral, and of course there's going to be grounding or bonding terminal as well. All right. Well, let's just see here. Connect the travelers. Okay. Connect the travelers. See, we're traveling through the boxes here. All right. Travelers are connected. Then we are going to connect the common to load, either or. Let's just say this one here. Then we're just going to go, let's say, that way here. And we're going to connect that right to the load. Okay. And then load to neutral. So we can just go and just make a little hoop-de-loop here. Hoop-de-loop here. And that is going to be our neutral wire. Right. All we have to do now is connect this hot wire. Maybe we can just move it over here. We're going to connect the hot wire right to this common, to the other common, other hot. Power to hot, or sorry, power to common. There we go. Or we can just go hot to common. Yeah. All right, so hot, that's coming from the power source. Electrical panel goes to this box first. Then it goes through that box, through a pipe that connects these two boxes, goes into this box, and it just goes to the other hot, or the common. All right. So here's our neutral terminal. Here's our hot terminal. Can we verify the signal path or the current pathway? Let's see, the switches are flipped, let's say this way here. Right. So now, the current goes from the hot to this common, and then it goes through that traveler, travels here, whoops, again, whoops, I did it again. The light bulb is off. Well, let's flip this switch. So it's connected this way. From the hot, it goes through this box, then it goes through the common, continues through that, goes through this comma, and comes back here, goes through the light bulb or through the load, and it goes right back to neutral. Can we flip this off here? Yes, we can. All right. So now the light bulb is on or off. Obviously, this light bulb is going to be off. Goes from the hot through this common, goes through this traveler. Whoops, the light bulb is off. Okay. Now, if you understand this concept here, then you're going to have a very easy way. Now, some of the more complicated, if you have more switches that you have to apply in the four-way switches, then yes, sometimes you're going to have to jot things down on a piece of paper. But now you understand how this is done. Now let's just go back to the first scenario here. Now, that's pretty much all that I have to say. So let's just go back to the first one here, because this is getting a little bit complicated. So as a review of what we have done, we're just going to go to the first scenario, which is basically visually the easiest to grasp. Okay. That stupid ring, phone ring that I have to. All right. Not opinionated at all here. Okay. All right. So let's just, where's my marker? Here it is. The first scenario was, there was a switch, three-way switch right here. There's a three-way switch right here. Over here. And there was a load in the form of a light bulb. Here's a box. Here's a box. And here's another box. We got three boxes. This is common. This is common. Here's a traveler. Here's a traveler. Travelers, and the light bulb has terminals here. Okay. So, and the power again is supplied from this one here. Now, right now, the first scenario I gave you was this, and you were watching what I was doing. So now my guess is that you're going to be a little bit ahead of me with your thoughts. So you will know exactly what I'm going to do just before I do it. All right. So let's see here. Connect travelers. All right. Traveler to traveler. Boom. Done. Common to load. Common to load. Let's say here it's going to go right here. All right. Another terminal of the load goes back to neutral. Kaboom. Goes right here. Of course, we're going to go through this box here, and then we're going to pass through this box, and it's going to go right to neutral. This is our neutral, and then hot to common. Bang. All right. Here is these are our poles of the switches. Do we have the light bulb on? Okay, so here's hot. Of course, there's going to be ground here, or bonding. Hot travels, current travels. From here goes to common, goes to this traveler, travels through that. Connection is made, goes through the light bulb, and it comes back on the onto the neutral. Flip it again, flip the switch this way here, and this light bulb is off. But if we flip the switch this way, all right, we have again current pathway, and the light is the light switch. The light bulb is on. See you guys. Okay. Now, so in reality, what you're going to have is going to be this. Anything that travels through the box is going to be connected through the wire nut. All right, so there's going to be a pigtail happening here. All right. Where else are we going to have a pigtail happening here? Over here, there's going to be also another pigtail. Made of two wires, all right? And where else we're going to have a pigtail? That's pretty much it when it happens to this. So we're going to have two pigtails when it comes to that. Why is it that we are going to have to create the pigtails? Right. I'm just kind of trying to see what's going on in the chat lines to see if any anybody has a question. I'm just, you know what? I'm just gonna go and flip through here. Hopefully, you're not talking about video games here. Jack here with the closed captions. All right. You can't have neutral wire depending on any specific. You can't have neutral wire depending on specific. With a pigtail. Yeah. Yeah, the ground or the bonding, yes, but neutral, it has to be a proper connection. I think that's what you were saying. You were talking, you can't have, so it must be done with a pigtail. You can disconnect device without compromising the neutral. It's, yeah, okay, there you go. All right, why is it that we are installing pigtails? And this is going to be part of our lab. Right after, it's going to be the, not next lab that we're going to do, the last lab after the next one, because the next lab is going to be bending pipes. We're going to bend the box offset, And then we're going to use that piping in order to create this situation. And we're going to actually light the light bulb with those switches. Now, why is it that we have to make pigtails when the wires go through the box? Why can't we just pull the wire through the box and just straight line? Technically, you could, okay? However, and basically, you're going to see that you're going to have, every year I get the question being asked, why is it that we can't just go? So we're going to have a box, electrical box here, lights, 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 lights. You're going to have electrical box here. You're going to have electrical box here. It'll be connected through the conduit, and there's going to be a short piece of conduit as well. It's going to connect to the light bulb, which is going to be mounted in the lamp holder, and there's going to be a white neutral wire going right from here all the way to the light bulb. And I'm going to ask you to cut that wire here, make a pigtail, cut the wire to make a pigtail, and have this thing connected that way. Why is it that I'm going to ask you to do that? Well, the reason for that is that if you are going to be hired in order to connect something like that on your desk with those little conduits right close to each other and the switches close to each other and the lamp holder close to everything else, yeah, I can just run the wires, done. Okay, but in reality, what you're going to have is you're going to have some box somewhere downstairs. There's going to be another switch or device box somewhere else in the building or in the room, and then there's going to be conduits going maybe to the light bulb, to the lamp holder. So you're not going to try to have one continuous run, especially if you are if you're dealing with installation with larger amount of devices. So basically what you're going to do is you're going to pull wires from one device box or electrical panel or whatever else, the supply terminals, to one box, terminate that. And you're going to have another set of wires, just like this is going to be a conduit. Now it has 1, 2, 3 wires if you don't have ground and if you don't have the neutral. But actually, yes, you do have the neutral, so we don't have to worry about pulling extra wire to have neutral there, because this box has a neutral, this box has a neutral, and this box has a neutral. And the grounding is going to be carried through the metal conduit, if it's a metal conduit, or it's going to be have to be another green jacketed wire pulled in through the pipes if we're dealing with PVC conduit. Okay? And here's also a pipe, a conduit. So in this conduit, we have 1, 2, 3 wires. You have 2 wires. So in reality, if you're dealing with a construction site, those boxes will be scattered all over the place. And through first part of the installation, if it's a new installation, you're just going to run, you're going to spend nice few days, if not weeks, just running the wires. Okay. So in order for things to be efficient, you're just going to run it from here to here, trim it, and leave it, okay? Run it from here to here, trim it, and leave it. You're going to label those wires also by those stick-on labels, and you're going to make notes, which numbers, because if it's a single conductor that you're going to be pulling in pipes, sometimes you're not going to use conduits, but you can use the 14.2 wires or 14.3 wires. Then you're not going to use conduits if it's a wooden structure, so the situations will be different, and you're going to be labeling wires and making notes. So you're going to terminate here. So that's why I'm going to ask you to actually make the pigtails, and we learned how to make the pigtails last time. Right? So it's all kind of falling together as we go along, and I'm going to show you how to make proper wire dressing inside the device boxes, so you're not creating some sort of a bad haircut mess in the boxes, and then you're not going to have a control over over the actually compacting all those wires inside the device boxes. Right? So as a review, and we're going to continue with this idea tomorrow, and I'm going to actually show you how things are connected tomorrow. So stay with me, okay? As a review, remember what we did? You might want to kind of write this one down. Connect the travelers. This is just a three-way switch with two switches. Things can get a little bit more complicated. So it doesn't matter what the arrangements you have, what the arrangement you have. Connect the travelers. Kaboom, kaboom, right? Common to load, common to load. The other terminal of the load goes to neutral and goes all the way to neutral. And then the other hot goes to common. Okay, so the neutral travels through that and goes directly. See, it doesn't go through it doesn't even touch the switches. It just goes through the box, but it's not terminated to the switches. Okay? It just bypasses the switch. And the hot goes to the common, and basically through the traveler line, through the line travelers, the hot is carried to another common, either through this traveler or through that traveler. Okay? And then it goes to the load. Notice that the only thing that is directly connected to the load is the neutral wire. The hot is switched. The hot terminal is switched. The neutral terminal is connected directly, pretty much uninterrupted electrically, right to the neutral. Okay? Now, just one last question. I think. I'm just reading your chat lines here. Okay. Just one last question, if somebody can answer me. Now, actually two questions. Which, in this conduit here, so that's a conduit, there's a pipe going from this box to this box. Which wires of these three are considered to be current carrying conductors? Jonathan said travelers. True. Top two. Any other answers? All right. Okay. No cookie for anyone. Someone says, well, okay. There you go. Cookie for Taylor. Tyler. All right. All of these conductors are considered to be current carrying conductors because under normal situation, they are required to carry the current. If there was non-current carrying conductor here, what would the situation be from what we just said? Looking at the chat line, I need Jeopardy music. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Okay. What was the question? All right. If we had to include a non-current carrying conductor, what would the situation be? Ground? Yes, that would be ground. It's a safety conductor. We don't have one here, but the situation would be if this was a PVC system, PVC raceway system or conduit system, then we would have to pull another wire with it because the PVC does not conduct the electricity, so the ground cannot be carried through the metal parts of the whole system. And then yes, the PVC device boxes, they do have extra grounding terminals that you can connect the ground or bonding terminals. Okay. Yeah. All right. So Now, the last question is, just forget the other situation, just what you see here. Out of these three, yeah, which is the conductor that is working the hardest, or which is the conductor that works the most? I can see an answer that says bottom traveler, neutral, white. Yes, the answer is neutral. Quentin, thank you. Joey, thank you. And then there's neutral, yeah, Kimberg. All right. Why is it? Because it always works. This one works sometimes when the switch is flipped this way here. So now this one works, this one doesn't. If the switches are flipped the other way, then this one works, this one doesn't. And this one works all the time, because it doesn't matter if this one works or that one works, the electricity travels back on the neutral. All right. Digital test in 8 minutes. Okay, guys, I'll see you tomorrow. And this concludes today's lesson. Now, try to get a piece of paper and do what I did with different type of arrangements, and see if you can just replicate what I did by rearranging the devices. We're good. By rearranging the devices and rearranging the way that the power is applied. Okay? If you do this, you're going to basically make it's going to be simple for you. Right? Okay, I'll see you tomorrow, and have good luck on your test. All right, thank you guys.